Alright, so sometimes it's nice to know why and where things come from, and this is one of those lessons that I think you can very kind of struggle with. So we're actually going to do, we already did Tuesday on it. We're going to spend today, tomorrow, Monday we're going to review it, and Tuesday before you guys go into Thanksgiving break, we'll have like a quick quiz on it. So we have shortened periods, and since we're spending 5 days on it, I really want to make sure we know that we have it before we move forward with it. So we are only looking at piecewise. Piecewises were first introduced by Newton, the physics guy as well. So he was introduced by Newton and Leibniz way back in the 1600s. They arose from issues that these mathematicians were having in calculus. In the 1700s, Euler and Bernoulli added to it, and now today it is an extensive part of algebra and trig and calculus. So we are in Chapter 2, Section 6. This section is about special functions. Your quiz on Tuesday is only going to be on piecewise. When we come back from the Thanksgiving break, we're going to start with step and absolute value. So, with a new section comes some new vocabulary. We have 2 words we're going to talk about today. We have piecewise defined function. So this is a function that is written using 2 or more expressions. And what we do is we apply different domains to these different expressions. We call those vertical lines you were drawing in, we call those vertical lines transition points. A transition point is the x value where the function changes from one graph to another. Sometimes I will refer to transition points as breaking points. So another name for a transition point would be a breaking point. So what I want to look at right now is the breaking point of this first graph. So you can see right here that expression 1 is 1/2 x plus 3, expression 2 is negative x plus 3, and the domain is split at 1. So we call 1 our breaking point. If I wanted to know what values apply to x less than 1, I look at the domains and I say, oh, x is less than 1 is the top expression. So if I want to know what values of x to plug in that are less than 1, I'm going to plug them in to 1/2 x plus 3. If I want to know what values to plug in for x being larger than 1, then I'm going to use the bottom graph, or negative x plus 3. Where do I plug in 1? Which value actually gets 1? The top one or the bottom one? Which one includes the 1? If you were drawing a number line graph, and you had to draw out a number line, the first number line, you'd have -1, 0, 1. Would I have an open or closed circle on that number line? Open. So it'd be open, and then where would you shade? Left or right? Left. So the top graph would be a number line, open at 1, shading left. The bottom graph on my number line, would it be open or closed? Up. And then would I shade left or right? So can't you see that my domain is split at And the 1 is included in the bottom expression. So the 1 is our breaking point of the graph, and it's going to be included with negative x plus 3. So what we're going to do is we're going to fill in the table of values that the domain applies to. So, negative 1, 0, and 1. Top or bottom? Top. So, negative 1 times a half plus 3 gives 1/2 times 0 plus 3, 1/2 times 1 plus 3. And we already said that this would be an open circle. 1's on my table of values twice because 1 is my breaking point. Let's graph these. We have an open circle at 1, 3.5. And I have an arrow at the end because it's all values less than 1 on x. 1, 2, and 3 plug into my bottom function. So that's like negative 1 plus 3, which is 2. Negative 2 plus 3, just 1. And negative 3 plus 3, which is 0. So I have 1, 2, where this time, because the 1 is included, this gets a closed circle. 2, 1, 3, 0, 4, negative 1, 5, negative 2. And again, this graph is extending for all values bigger than 1, so it continues in that direction indefinitely. What does that do to the domain of my function? What does that make it? Does every x value in the entire world have a value for y on it? If I plug in x equals 100, am I going to get out a number? Great, because I plug it in here. So if I plug in 100 here, I get negative 100 plus 3 and get negative 97. So every value for x will give a y value, making my domain all reals. What about the range? Am I going to get a y value of like negative 10 ever? Let's go a y value of negative 97 if I plugged in 100. So do I think I'll probably hit negative 10? How about positive 10? Are either of my lines going up ever? So can I ever hit positive 10? The highest point on y I'm ever going to hit is this open circle right here. Now I don't actually hit that point. So kind of like the 1's not included on the domain, 3.5 is not included on my range. So y is going to be all the values less than, but not equal to, 3.5. So, in example 2, once again, I have a breaking point. The breaking point comes from the inequalities over here on my domain. So in this case, my breaking point is at 2. And what I've done is instead of making 2 tables, I just give you one long table. You can still do 2 tables like we did on the piecewise cutting out activity. That's okay if that helps you see it better. Now, Which equation is going to use 0, 1, and 2? Well, if I put 0 in for x, is 0 greater than or equal to 2? Is 0 less than 2? So I'm going to plug 0 in to the bottom equation. So 0 times negative 1 plus 4 is 4. Negative 1 plus 4 is 3. Negative 2 plus 4 is 2. So plotting my points at 2, is it open or closed at the breaking point this time? Open. So at 2, 2, it's open, closed at 1, 3, and closed at 0, 4. So this line is continuing positively on the y's, upwards and outwards to negative infinity on x. Then my second equation, x plus 2, is going to be all the x's in the world bigger than 2. So including 2 this time. So 2 plus 2 is 4. 3 plus 2 is 5. 4 plus 2 is 6. So you plot the point 2, 4, 3, 5, and 4, 6, continuing towards positive infinity. Once again, does my domain include every x value in the world? It goes to all the x's less than 2 and all the x's bigger or equal to 2. Therefore, my domain is all reals. What about my range? Is my y ever going to be negative? Is my y ever going to be 1? Is my y ever going to be 2? It gets infinitely close to 2, but it's never actually 2 because it's an open circle at 2. So my y's are going to be greater than 2, but not equal to 2. Would this pass the vertical line test? Yes. Because this is closed and this is open, it passes. If they were both closed, it would fail. So yes, it is a function. Is it a one-to-one function? No, because does it pass the horizontal line test? No. So it would not be 1, 2, 1. Just going back, reviewing some of that vocab from before. So this one has 3 breaking points. We have breaking points at 2 and negative 2. So now when I do my transition points, they have to be at negative 2 and at positive 2. And I need to figure out, okay, where did these 3 points plug in? Where do these 3 and where do these 3? So I have to go back up here and ask myself, if x is negative 4, negative 3, and negative 2, which equation allows for my x's to be less than or equal to the negative 2? And that's going to be this function here. So I'm going to plug into that function. Ask myself, which function goes from negative 2 to positive 2? Well, that's the middle function. So this is a horizontal line. Therefore, all of my points are at negative 3. And at the bottom, when is x bigger than 2? Well, x is bigger than 2 for the top equation. So I'm going to plug everything here into the top one. So 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3. This is an open circle because it's not included. And my graph goes up. Here at negative 2 and 3, this is actually also a closed circle. And I hit into a problem of, is this a function? No, it fails the vertical line test right here. So the domain and range are as follows. And here's your homework.